All right, I think we will start the event. We have a good number of people that have joined already. So thanks for joining Cluster Market's 7th Lab Talk, Advancements in the Technology and Best Practices for NMR Spectroscopy. My name is Sam Choi, and I'm a lab consultant at Cluster Market, and I will be the moderator of this talk. There are quite a few people joining in, as I can see in the attendee list. Some are familiar names, others are new ones. I can see people joining in from all over the world, actually. I recognize some names from Cambridge, others from Madrid, Delft, Lisbon, I think, London, and even Florida. So for those who don't know us, Cluster Market is the leading lab scheduling system for R&D labs, and it is used by many NMR facilities around the world. We have recently reached a very important milestone, which we're very proud of. Now we have over 100,000 users on our platform. We're very excited about our strong NMR community, and today's talk is all about NMR. I am happy to discuss best practices and tips with our wonderful guests who actually use our platform as well. We have Johanna Becker-Baldes, Elvin Janssen, Konstantin Lusjanin. I will do a quick intro of each of our speakers, and we'll get started. Johanna runs the solid-state NMR DNP facility at the BMRZ, which is Center for Biomolecular NMR at Goethe University Frankfurt. This lab is headed by Clemens Globitz, and their research focuses on the function and biophysical properties of membrane proteins, which they study under magic angle spinning at high fields. In addition, they use DNP enhancement techniques on these systems, which, for example, enable them to study intermediate states. Thank you, Johanna, for joining us. Next, we have Elvin. Elvin works at Vrije University Amsterdam. He's an organic chemist. And a few years ago, he became the manager of the NMR core facility. Elvin is responsible for the maintenance of 3 spectrometers and assists and advises students and researchers about structure elucidation of small molecules by NMR. Together with his team of researchers, he plans to implement metabolomic studies and STD NMR to their laboratory. In addition, he teaches 2 NMR-related master courses, each on a different track. Thank you, Alvin, for joining us. And then last but not least, we have Konstantin, who he is the academic head of analytical services and senior lecturer in the Department of Chemistry at University of Liverpool. He completed his PhD at the University of Lisbon, where he was later a PI of a research group and a manager of the largest NMR facility in Portugal. Since 2012, he has been overseeing the analytical facilities of University of Liverpool, which include NMR spectroscopy, among other instrumentation. They offer support to both teaching and researching, including 50 research groups from various departments. Their NMR facility includes 8 instruments ranging from 200 to 500 megahertz that are used in mixed automated and hands-on modes according to users' expertise and equipment type. Thank you very much, Konstantin, for joining us today. Just to get started, I would like to ask Johanna in particular, what are some advancements in the NMR field? This could be techniques or new exciting technologies that are up and coming.
Yeah, I think I of course have to tell you things about the solid state NMR perspective. And in the recent years, we have seen the development of ultra-fast probes, so which means we can spin the rotors, which are then very tiny at 100 kilohertz, and detect protons as we have been doing in solution all the time. And this allows us to reduce the amount of sample enormously, and also, of course, gain access to the proton chemical shifts, which is really nice. Other advantages are we are now start to use a lot of these optimal control pulses, which makes the setup of experiments often faster and easier, or possible at all if you have a very tiny amount of samples where you can't really optimize these cross-polarization steps, which we do need. Maybe just, 2 examples.
Okay, thank you. Thank you, Johanna. How about you, Konstantin? Are there any new and upcoming interesting tech or techniques that you are using right now?
I believe in NMR spectroscopy, from my perspective, as more a solution person rather than solid state. I would say the main advantage that we bring now are the widely available cryoprobes that are not helium cooled, but nitrogen cooled. So they are known from Bruker as cryoprobe prodigy. So they are, the cryoprobes are known for decades. They're used, but they're used primarily by biologists. And it's due to very high, very elevated running costs. But nitrogen-cooled cryoprobes, they are significantly cheaper to run. And we can even now afford giving access to the cryoprobes to our postgraduate and undergraduate students. That was not possible years ago. And also, I would like to mention one new thing also that was recently brought to solid state NMR. So there are new types of probes that are now fully automatic. So that means that there is no need anymore to manually set the magic angle spinning, for instance, so they can be done in automation now. So we hope that we could in the future benefit from these by making solid state NMR as accessible as solution NMR now.
And thank you for those insights. And lastly, Elvin, do you have any comments to add on new technologies or techniques that you've been implementing?
Yeah, so we only have solution state NMRs. And for that, I have to go with Konstantin about the Prodigy cryoprobe. We have two helium, let's say, cooled cryoprobes, one in use and one is standing aside. Indeed, maintenance costs of these cryoprobes are quite high. And so we do not have a Prodigy cryoprobe, but I certainly think this is a good development in getting better SN ratios and more sensitive measurements. Absolutely. Other than that, we are currently not investing in super new technologies, just currently.
Very well. Thank you everyone for your insights. And now I wanna change gears a little bit, I guess, and talk more about lab operations, which I think a lot of the lab managers that are present right now would benefit to know how other labs are running their operations and how they're dealing with different issues that arise while managing a lab. So could we start maybe with general insights within lab operations? Would you like to start, Konstantin, since you have, I think among us three, the biggest facility?
Yes, so well, we have technically, we just merged with biology, so technically we have 11 instruments now divided by 2 sites. So we have 8 instruments in chemistry and 3 in chemistry side, and we have 3 instrument, high field instrument in biology. So this is a university-wide facility, but chemistry side, due to the specification of instrumentation, mostly fits to chemistry, engineering, physics, and research in exact sciences, while biological samples are primarily analyzed in biochemistry side. So we have a mixed mode of operation. So we have 8 instruments. So there are some specific instruments there that can only be operated manually. For instance, we have very unique high pressure NMR for gas phase. So when we also have some solid state NMR instruments that they are operated manually by experienced users, but majority of the instruments are operated in automation. So we use booking system, well, cluster market booking system that is used either for getting access to the manual operated instruments, or for automation, where we use that time that is booked primarily just an access time. It was not driven by the COVID, but it was just an idea because we have a very large number of users. So we currently have approximately 150 regular users. It's just not possible to have queue in front of the NMR facilities for people. It will be just not efficient. So we use booking system for users to get access to specific instrument at specific times. So that's how we operate. So users book their time, they bring their samples, they submit them, but we do not use booking system to account for amount of hours that is used by users for NMR, because, well, every user have a right to measure what they want suitable, what they find suitable from the list of experiments. So it would be not possible for them to, let's say, decide in advance how long the experiment can take. They may adjust it in the middle if they want, in the middle of the run. So we use primarily booking system for access to the instrumentation.
Okay, excellent. Thank you, Konstantin, for sharing that information. Elvin, how do you manage things in your lab then? How do you operate things on your side?
Yeah, so our lab obviously is quite some smaller than Konstantin's lab. So we have, like you already said in the introduction, 3 spectrometers. And we have to divide that over 20 to 60 people. It fluctuates because we are also heavily involved in teaching. So we give practical courses, and then sometimes we can add 20 to 30 bachelor students, for instance, in addition to the users. So we use, of course, also the cluster market booking system. People have to book. 2 spectrometers are just walk-in systems with other samplers. And then our 600 megahertz is only for the higher, let's say, more experienced staff with the cryoprobe and as well. And then I spread the level, let's say, of experience over the spectrometers. So the bachelor students go to the 300, master and bachelor go to 500, and PhDs and postdocs, they go to the 600. So I have to spread that a bit because yeah, we only have 3 spectrometers, and if one breaks, then we already have less alternatives than when you would have 9 spectrometers, I can imagine. So to minimize the risk of damage, we have allowed most people only to use automation. Only a selective amount of people know how to measure manually, because we also have external clients, and they also need to do their measurements. And yeah, I have to take good care, of course, obviously, as every manager, but we have sometimes relatively a lot of people for a relatively low number of spectrometers. So
yes, makes sense.
Yeah.
Thank you. Yeah, go ahead.
Oh no, sorry, no, it's yeah.
Okay, thank you, Elvin. And lastly, Johanna, you focus more on research. So
Yes.
could you share a little bit of how you run your facility?
Yeah, so it's a research lab, so much fewer users. It depends, maybe 10 or something, and they have quite long measurements. And so my main task is to collect the requests and then to work out a plan that you make sure all the weekends are covered, all the nights are covered, and we don't have gaps in the NMR schedule, or to make sure that, you know, people that use similar experiments, they measure after each other, so you don't have less probe changes or things like that. And also, not too rarely, I have to also book my own time, because then I know these are experiments or these are setups where I need to support these people. And this is also something that has to be taken into account, especially, I didn't say at the beginning, we also have DNP instrumentation, and users need quite a lot of training to be able to use that independently.
Okay, thank you. Thank you very much for giving us a fully research-based focus on your facility. Just to implement more discussion amongst our panelists, I just want to ask how you manage maintenance in your facility. Do you tend to do it yourselves, or do you have a technician in your team that takes care of that? Or do you use OEM solutions, or do you have a third-party contractors, for example? How do you do things, Johanna, in your lab?
So we are very lucky. We have a very well-trained or knowledgeable, I don't know how a knowledgeable technician. He knows a lot about all sorts of hardware. So with him, my main task at the moment is, when something breaks down, is to analyze which part of the equipment is failing. And I think most of us have seen changes a lot by the main manufacturer of the NMR machines, that support by them has been reduced, especially regarding hotlines and things like that. So we really have to know what is the problem and which part to order. And this analysis, yeah, for this, you don't need to know that much about NMR. You have to know about amplifiers and, I don't know, electricity and all these things. And we are very lucky to have very good support here. And we are a good team, I think, to figure things out and to keep things running, and or to find some ideas what to do, or to some workarounds. And it's, yeah, and then only then we have usually we know very specifically what we have to ask the vendor of the NMR machines, what to provide, which service or which spare parts.
Makes sense.
I don't know how the others do that.
Yes. So how do you do things constantly in your bigger lab?
Well, I have fantastic colleagues who have expertise, who share expertise in mass spectroscopy. So, as Johannes said, it's not always only about what experiments to measure. It's also necessary to have some expertise in what parts are required and how the parts may affect your measurements. So, well, it's a joint work. I also have a team of technicians, analytical services technician, but most of the work, it's, I would say, the basic service and basic maintenance, like cryofields, for instance, that's basically normally done at the technician's level, but something more serious, it's mostly done in discussion with colleagues. We don't have service contracts, unfortunately. Well, as for large facilities, we all know that it is nearly impossible to get service contract due to the very high costs of those. It's for 8 NMR instrument, the service contract probably will be larger than the budget that exists in the university. Just too expensive. And we try to do as much as we can based on our expertise in collaboration with colleagues. Some things obviously we can't do, so then we need to have ad hoc engineers visits or send parts back to the factory. So I guess in the large facilities, it's always like this, something we do ourselves, something we can't do, and then we need to invite somebody.
I think it also is, just to add to this, we are all have a kind of research. Yeah, we are serving research people or doing research, and there's always some downtime, which is simply there, and people accept that. And it's not a hospital where some patients are there which need to get this done. And it's unfortunate, and we try to do our best, but I think the cost of these maintenance contracts, it is not in relation to what the risk, a downside means.
Makes sense. Makes absolute sense. Elwin, how do you do things in your facility for when something breaks down?
Yeah, so I'm the manager, but I'm also the technician. So I'm actually doing everything myself. I mean, I have to as much as I'm able to. So I'm also, like you said in the beginning, I was quite known with the interpretation part of NMR, but just a few years ago I came into the management of the facility, and so I also had to learn about the pulse sequences and about the maintenance, all these things, and that's quite another expertise. So I still need to learn a lot about that. But over the few years, I am able to fix some things. I totally agree with my other two NMR facility colleagues that the costs of the vendor, let's say, they have risen quite substantially over the years. So I also try to email and ask questions to fellow colleagues in the Netherlands who maybe can provide me with advice to solve some things. And
so network is very important in these cases when you don't have the resources, right, to do things on your own.
It's very many fellow colleagues, they recognize your issues you have with hardware or other things. And but still I have also good contacts with someone from Brugge, a few from the which is the main vendor of our facility, and they support me sometimes also with very good advice. And as far as I'm able to, I try to solve it also via that way.
Okay.
But no third parties for us. No.
Okay, makes sense. Makes sense. So I just want to do a follow-up questions. What do you think are some of the pros and cons of, if you have the budget of, being able to have these contracts or use third-party contractors versus doing it yourselves or within an in-house team? What would be the pros and cons of each?
Well, if I would be given a budget, that would be the first thing what I will do. It liberates huge amount of time for research, and it liberates huge amount of time for teaching. And also it's for the large facility like ours, maybe if we have one instrument that requires service and it's down, it's normally not that noticeable. But for the smaller facilities, getting one instrument off is very significant. So that's why even for large facilities, if I would have money, I would absolutely go for the service contract. I manage several types of instrumentation. Analytical services have approximately 25 different instruments. So that's why for those instrumentation where we can afford service contract, we do it. It also guarantees, we have instrument that maybe one per university, so we cannot afford having it down. So that's why obviously service contracts also guarantee it's not that much that it's cheaper or something. It also it's generally faster because on service contract the companies give priorities to the customers with service contracts. But if I would have enough budget to cover NMR, I would definitely go for this.
Okay, definitely makes sense. How about, Johanna?
Yeah, I just thought, I think it really depends also on your type of NMR machine.
Yeah,
because I think if you, it's for the routine things where also you have the routine problems and the companies can, if they have time, help quickly. I think for this, my feeling is for the very special applications. I think probably I don't know if they even offer a service contract, but probably there we need to know by yourself because it's like a DNP machine that there's so many things that have to work at the same time, and you have to understand the system by yourself completely, and you can only do that if you do the troubleshooting with the help of Bruker. Maybe that's nice, but I think that's if you cannot call them every 4 weeks, and that's how often these machines have problems.
Yes, makes sense. Elvin, anything to add to this, pros and cons?
So we had a service contract for our cryoprobe. This was the last year, 5-year contract, and that went well. And the pro of obviously is that you know that somebody maintains the hardware and who is skilled and licensed to do that, and there is guarantee. If you do not have the expertise, then of course you may risk that you damage something, and the costs might be even higher if you're very unlucky. With everything, you need to do certain things a few times before you do it the correct way. And so then it's good that you have a skilled person in the vicinity who can teach you those things. If you don't have that, then you have to be a bit more careful and maybe ask the vendor indeed to come by to do it 1 or 2 times, certain things, and then you can, there are things you can do yourself, absolutely. And if I can, I definitely will do that.
Okay, makes sense.
If I may just add to what both of my colleagues said, it's absolutely. For instance, in my facility, my own NMR, there is one taboo that we never touch. At least I never touch. These are probes. Because NMR probes, in particular, well, cryoprobe is absolutely out of question, because when I've seen what's inside this cryoprobe, I've decided that no, I will never touch it myself. But yes, everything absolutely. If we can do something ourselves, like traditional probes, room temperature probes, cleaning and coil replacement and all these things, we could do ourselves. sometime. But the more complex probes, more advanced probes, we need Bruker to service that. If I may just also, there is one question in the question and answer panel about the using other independent service providers. Well, for NMR spectroscopy, I'm not sure that even exists. At least in the United Kingdom, I'm not quite sure, because Bruker usually does not disclose the specifications and the blueprints of their parts. So basically, if there is a good chance if we contract somebody who is not certified by Bruker to open the amplifier or open the probe and break something, and Bruker will simply not accept this later for repair, or the cost of repair would be very high. At least I never had experience of, I don't even know if there are any companies who provides NMR repair services. They might exist. It's just I never had any experience with these kind of companies.
I think there are actually companies, but also we're not using them, especially because if we send things to Bruker for repair, it's usually probes, and they build them, and I think they should repair them. And we have very special probes, and I think this is. But touching probes, I think if you do, you also have some solid-state NMR probes. I guess I think to have to open the stator is something that is probably not to be avoided, because sometimes a cap is lost or something, and then or the rotor is stuck, or I don't know. So these are things. But as soon as the RF is affected, this is really beyond what we can do. So these probes, they go to Bruker. Or if this data needs replacement, it's also something we're not doing. Although some colleagues do that. Data replacements.
So for all the attendees, if you have any questions, please put them on the Q&A. We'll revisit them at the end. We'll have a few minutes to answer questions from everyone that's here. So
maybe can I ask a question to Alvin? So if you
yes,
say you manage all these things alone, so how do you? So, but with Cryogens, you have somebody to support you.
No, I do everything alone.
Yeah. What happens if you're on holiday or when you're sick? Because
I haven't been on holiday for 10 years. No, that's not true. I have a backup.
Because I think that's also good, or sometimes lacking, that you, for certain things, then there's only this one person who knows something, and then
true.
Which is then not a hardware downtime. It's a people's downtime then.
Yeah. So with nitrogen refill, I have indeed a backup if I go for a holiday, and the same backup is also my, let's say, assist me with the helium refill. So it's always more convenient to do that with 2 persons instead of 1.
But we had a big discussion during this Corona time. What happens if 3 of us are in quarantine, and what do we do, and things like that. I guess it's even more difficult in a smaller facility.
Yeah, those were exciting times, but I didn't get sick, so that was I was lucky.
That's great. That's great. I would just like to ask, since we were talking about probes and how complex they were, do you have any tips for everyone that's here for increasing the lifespan of probes or the instruments in general? What kind of best practices do you have in place for your users? Could you start, Konstantin?
You know, this is a very difficult question. The answer can be very, very long. But if I may just approach it from 2 opposite sides. From the management of the facilities, naturally having more instruments is better, because the instrument obviously has lifespan, but they also have duty cycle. If we have 3 instruments and operate 100% of the time, we obviously reach the end of life much faster. But if we operate at 75% of the time, as we are usually recommended by the manufacturer, we will reach it much later. So we need always have a backup. We are lucky to have backup for some, but not for everything. And naturally, is more alternative we got is better. In terms of, from the user's perspective, this COVID situation taught us one very important thing. If our users will prepare samples carefully, and they will use gloves for everything, and they will wipe their tubes and not label them with the with the glass marker, then the lifespan of the probe is dramatically increased. Because, so I would say careful sample preparation and appropriate consumables for NMR spectroscopy, in particular tubes and cups. We restricted here the use of NMR tubes and NMR cups to specific type and specific manufacturer due to the reason if we allow 1 million different types of tubes, in particular disposable tubes that are frequently used in a non-disposable way, we break all our robotic interfaces basically, because the tubes either is too heavy or not sufficiently heavy, and basically it jumps too high or too low and breaks the parts of the robotic interfaces. So I would say, from user's perspective, careful sample preparation, cleanliness of the consumables, and also the restriction on the types of consumables that should be used, in our case, improve dramatically the usability and the lifespan.
Okay, great. That's some great insights for everyone here attending. How do you recommend doing things, Elvin?
So with the consumable part, I totally agree with Konstantin. Only specific type of tubes, not the cheapest ones. They should not break easily, especially indeed for the auto samplers. In addition to that, most of the users, they will use automation for most of their measurements. So then they do not come close to the magnets. The auto sampler inserts the sample. And in general, they use then standard experiments for their research. And if they require additional measurements, then I'll do that for them. For instance, a high temperature, or I have to change parameters in the parameter set. So I'll do that, or I'll train 1 or 2 people who are a bit longer here for research, and they can do that themselves as well. So I limit the people who do manual measurements. And then automation. We also have many bachelor students, for instance, who enter an NMR lab for the first time. You don't want them yet not immediately to do manual measurements. If you only have 3 spectrometers, let's say, and something breaks. So yeah, limit manual measurements is what I do. And then of course also ask them to buy good quality tubes. Yes, and definitely clean them. Yeah, absolutely.
Yes, makes sense. Johanna, how do you think on the solid side of NMR?
So most solid measurements are magic angle sample spinning. So we have these little rotors which spin very fast or not so fast depending on their size. And these rotors are very expensive, so they're reuse for sure. And the main point, or which I think is the most important in running a solid state NMR lab, is, of course, there's no automation, so we do everything manually, to train people how to realize when a rotor doesn't spin and what not to do with a rotor that doesn't seem to spin. So if a rotor doesn't spin at certain parameters, doesn't reach a very certain low spinning speed, we have defined that very precisely. Just stop. Don't continue, find a problem. Don't spin up a rotor that behaves oddly, because it will end up in a crashing of the rotor. Okay, then your rotor is gone, but also very often the stator is affected, and this repair is very costly and time consuming. So the probe will be away for at least 3 months, and the cost will be, I don't know, close to 10,000 euros. So you should really, really, really avoid rotor crashes. This is something you cannot avoid in each case, but you can reduce them a lot. And I think this has to be very clearly communicated to the users how to spin the rotors. So this has changed a little bit, because so things have changed since now there's the MIS3 spinning unit, and this is much more automated. This is good and bad at the same time. I'm not so happy with all of the profiles, so there needs improvement, I think, there, but also maybe reduces some of these risks. But again, I think even in this case, yeah, users should be trained to recognize a not well spinning rotor.
Yeah, it seems like there is a continuous theme across all the answers. Looks like you definitely need to prepare the users to teach them, to train them how to recognize issues and how to prepare samples correctly, not to damage the instrument. So training is something very important.
And I think you need an atmosphere of, you know, there is no stupid question, because yeah, it's easy to, after doing years and years of NMR, everything seems easy and logical, but yeah, each student generation has to learn things newly, and yeah, they should not be afraid to ask.
Yeah, definitely. That's a great comment. And I think we can apply that on everything in life, right? Not only for NMR. There are no stupid questions, even the simpler ones, definitely. Excellent. So since we're talking about tubes and consumables, do you do anything to reduce the waste of consumables in your lab? Elwin, do you do anything specific in your lab? Do you reuse tubes or something about the gas that you use? How do you take care of that?
So yeah, I'm fine. So if the correct tubes are ordered, I'm fine with reusing them several times. I'm just ask the users to check their tubes regularly, especially the top where the cap goes on. As soon as there's a crack, then they can use the tubes for other purposes than NMR. And I also always explain that so we use standard 5mm tubes. So 0.6 milliliters go in there for your 4 centimeters, which is the ideal height for the standard 5mm probes. And if they would use 0.6 milliliters, they can also save up the deuterated solvents a bit more. A couple of times you are quite able to see actually in a Pasteur pipette, these standard glass pipettes, how much 0.6 milliliters is, and then you can save up solvent as well. So reuse tubes, but not too much, not too often, and save solvent as well.
Okay, definitely. How do you do things on the solid side, Johanna? Is there anything you do to reduce waste or overuse of consumables?
So with the rotors, of course, everybody wants to have a lot of them and to keep or never unpack your sample in case there's a measurement you still have to do. So I have a list. So each rotor has a number. I have a list who has it, and then I ask people, are you really sure you need that many rotors? Can you give some back? Because if everybody has 2 just in case, you'll have 20 rotors which are not used, and they're really expensive. Another thing is then we have these little plastic inserts to center pack the sample, or the caps, and which need replacement. And I have a stock of these things which are more or less, if a cap looks odd, it needs replacement, of course. But I try to put not too many of these things in the box, basically, because if there's plenty, they seem to go fast. If there's just 5 or so, people seem to be more aware that this is not an endless supply.
Makes sense, definitely. How do
not
you?
Psychological, I guess.
Yes, the psychological pressure. How do you do things, Konstantin, in your bigger lab?
It's difficult to say, because I also want to say that we are trying to reuse the tubes and we are trying to minimize the amount of solvents. But, it's quite difficult in a large facility. And although the same rules obviously valid, we try not to, we restrict type of the tube, and we, in the United Kingdom, although we had before a number of suppliers of deuterated solvents, it's a bit more challenging now, because majority of the solvents are coming from Europe. And so the solvent's more expensive, the transportation is more expensive, the delivery times are much longer. So, it's naturally working towards saving on everything. But my major problem are the tubes, because the tubes are now so cheap compared to what it was 10 years ago, for instance. And it's quite difficult to convince users to reuse the tubes. We try our best, but unfortunately it does not work 100% of the time. Maybe if the tubes also will be of restricted access, maybe it will also improve the reuse. But also there is a second side of this, recycling and reuse. We strongly encourage users to inspect all the tubes all the time, because in particular with cryoprop repairs take forever. It's months of time. And so that's why we encourage users, even if they suspect that a tube is not symmetric anymore, or there is a crack, or it's chipped, or anything else, immediately bin it and get a new one. So it does not really help, because I think with my way of explaining things, users are scared that if they break something, they will leave the entire university without a cryoprobe. So that's why it's, from that perspective, we need to find a golden mean when it is still usable, but at the same time to ensure that the tube doesn't break inside. But I believe, Johanna, it's the same in solid state NMR. Sometimes, as you say, if the rotor doesn't produce similar sound and doesn't rotate in the same way, you probably would avoid using it and just get something else. It's probably the same in solid state NMR.
Yes, we have a rotor tester actually. So you can test, you don't even have to put a sum, you can test the rotor in this extra testing thing without risking a probe. And if it spins there, then you can put a sample, I guess.
Yeah. Just if I may add also one element of saving, that is, it's a bit of behind the scene. I think the main running cost, beside repairs, of course, are the cryogens, in particular liquid helium. And well, we are very lucky enough to have the helium recovery system that was built some decades ago by amazing German engineers that really worked up to recently. We currently make a major refurbishment, but it allowed us to recover nearly all boil-off helium from the instrument. So it was the full cycle system. It is a full cycle system that has not only the collector and purifier, but also has a cold box so that produces liquid helium. So we can recover and reuse this. That is a great way of saving, and it's extremely sustainable because helium price will only increase. It's a very rare resource, and with increase of the frequency or the strength of the magnetic field, magnets are becoming larger. So that's why in our university we invest into the recovery of helium, and we would like eventually to have every single instrument that use helium in that system. Whether it will be possible in the nearest future or not, we don't know, but at least we definitely will try.
That's super interesting. So I was just about to ask a follow-up question about, you know, cryogens and different gases that you use, and how if you have any tips for other lab managers to you know, reduce the consumption of these gases, if there are any best practices. Alvin, any insights there?
No, I would love to have a system like Konstantin has as well. I think that's the most significant way to save helium. And other than that, I do not know how I can more efficiently refill helium and nitrogen than I'm currently doing. Yeah, no, I would love to have a helium recovery system as well.
Okay, maybe you can ask that in your next budget for next year.
Yeah.
You know, it's if you're talking about the helium, the cryogens, for the very small facilities, the full system that produce liquid helium, well, if you have 10 NMR instruments, it is sustainable, but the initial investment would be huge. For the small facility that has a couple of NMR instruments, the partial system that only recover the boil of gas, and then you can sell it back to to the supplier of helium in exchange of some liquid helium would be significantly cheaper. We did a long exercise of calculating how much it will cost and what is sustainable and what is not. For the large facilities, for the like university-wide facilities, it's really sustainable, but over a long period of time, because that's very expensive investment. I would say 10 instruments would be my number where it is really makes a difference to have the full cycle system. For the smaller number of instruments, the partial system will work perfectly. You can have it with 3 instruments, even with 1 instrument, if you just obtain gas. There are many manufacturers, well, not many, but quite a few manufacturers of this system. It's become more and more popular. And even Bruker announced in the last month that they now built those systems to collect the gas and purify. It's a new generation that they're announcing in the NMR conference, or just announced in the NMR conference. Presumably in the next Bruker NMR user meeting, we will all hear about this. I don't know how much it costs, but if it's manufactured by Bruker, at least we know whom to approach if something is wrong.
Yeah, definitely. I think this is a very good tip for the partial gas recovery system for smaller facilities to implement. Definitely.
I think the main advantage of, we also collect our helium and liquefy it as a big facility. And the main advantage is that we get the helium when we need it. So we don't have to pre-order, and especially nowadays, there's at least a little bit higher security. Of course, this won't last forever, but I think that's also an advantage, not about saving and costs, but availability of helium is better. But yeah, for this, of course, larger facilities needed, I guess.
Yeah, definitely. And also supply chain issues, right, that we can see nowadays with transport and importing and exporting things. Which
that's the main problem, because as an NMR lab, you have, there's nothing you can do. You reduce your amount of helium, as Elvin says, and so there's really, so you're fixed with this amount and you need to get this amount, and you can wait a few weeks, but that's it.
Yeah, definitely. So it seems like you can have it, well, not immediately, but in a closer period of time, you can have helium at your disposal if you're recycling it. And definitely. Do we have any other best practices that we want to add or share with our attendees before we start wrapping up this conversation? Konstantin, anything else you would like to share?
I would say one of the ways of the efficient use, it's training of users. We invest a lot in training, so we train undergraduate students, and we are lucky enough to have one of the instrument in the teaching lab. So that's teaching NMR instrument. It's a full grade research instrument, so it's not a benchtop NMR. And we invest into teaching both undergraduate and postgraduate students. For PhD students, we provide specific module. It's a large module and different NMR applications. So we strongly encourage users to get as much NMR practice in manual mode as they can, because in particular, then PhD students reach the end of their PhD, there are always more complex experiments that are required that are not always can be achieved through automation, particularly if the time is limited. So I would say training and teaching of NMR spectroscopy is essential for us.
Yes. Perfect. Johanna, any other last best practices to share before we move on to the questions that we have?
Yeah, maybe one thing is for some routine things which have to be done in a certain way. I do have little, recipes or how to do this, and these pieces of paper are at the NMR machine, and there are users that read them and some don't, but the users that read them, they actually also tell the others about it somehow. So just to keep this knowledge not only available by information from me, but to have some other ways to access this. This we can still improve a lot, but for me, I think this is also useful.
Yes, definitely. So sharing your tips and tricks within your lab for other users to be able to apply them for their experiments. Elvin, any last comments for tips?
Yeah, maybe a bit of follow-up of what Johanna just said. I regularly visit a few research groups which are using the NMR facility. And there I give a short presentation about what experiment could be handy for their research. And then I contact one of the researchers and use one of their compounds to actually show them, the people of that research group, how this or that experiment could work for them. Yeah, you sort of spread the knowledge what else is possible than these basic proton and carbon and cozy experiments and things. Mm-hmm. Yeah, so that's
okay. Excellent.
So
thank
keep
you.
the people informed. Yeah.
Yeah, thank you. So looks like training and communication is very important for keeping your lab running efficiently. So I would like to just wrap up a little bit, and we'll move on to the questions that we have. We'll start with one here that says, could we use NMR to characterize nanoparticles? I'm assuming these are more chemical nanoparticles, maybe. So Konstantin, could you take a crack at this one?
It's a difficult question because I really don't know the answer on it.
Okay.
If it is in solution, if it is, I only have experience with the capped nanoparticles, those that have ligands attached to them. So presumably those can be characterized. But there are more efficient methods to characterize nanoparticles. In particular, if they are relatively small nanoparticles of a couple of nanometers, they will behave as basically molecules in solution. So there would be standard solution NMR then applied, and they can be characterized. But the larger nanoparticles, above 10 nanometers, they will already behave, from my understanding, will have a solid compound. So probably they can be better analyzed by the solid state NMR. And I would say we have nanoparticles groups here. They use NMR, but in a very limited way.
Mm-hmm. Okay. Johanna, can we do this via solid state NMR?
As Konstantin said, it really depends on the type of nanoparticle. As soon as you can sediment it, you can do this. I think when you want to do this, you really have to know your question. And sometimes there are some, you could maybe, whether you look at the surface or the inner part, you do some CP experiment to filter out some things where you have hydration on the surface and no protons in the inner part, and do something like that. But it really depends on your question, but I would also guess it's more a solids application if it's a nanoparticle.
Okay.
And whether it's useful, yeah.
Okay, thank you, Johanna. Elvin, do you have any insights or experience with nanoparticles?
No, that's quite out of my comfort zone, so I cannot give any useful information about that.
That's good. That's all right. We have another question here about test tubes. It says, how do you check test tubes for misalignment? I usually roll them carefully on the bench, and if they roll oddly, I discard them. Well, I guess I did that during my undergraduate as well sometimes. But Elvin, do you have any other tests that you can do other than visual looking at it at the test tube? Do you have any other tips?
No, only visually I test them, and indeed rolling or testing prevent them from being dried in ovens are classical things to prevent it. But to check it other way than visual ways, no, I don't have any tips.
Okay.
I never rolled tubes. I never rolled tubes during my PhD and during my studies. I don't know what means misalignment, and it's from the perspective of the quality of spectra. I would like to say that our users just measure the spectra and see if the resolution is affected, then they just move the solution into a different tube. I don't know really. We never made any test of alignments. We try, as I mentioned, we restrict the type of the tube that we get, and those that we get, the manufacturer guarantees that they checked one by one. Oh, okay. So that's why I don't really know. Presumably for disposable tubes, I remember when we used them before, they there are sometimes black sheep in the amount of those tubes. So just basically by measuring spectra.
Okay. And then I think we have one for the solid state side for Johanna. How do you manage the rotor test? So how do you do that? And for example, where you could get one?
So this rotor test devices, you can buy them by broker. They are very expensive, as usual. And we have the form, not the version that's sold today, but the predecessor of that. And there's no management needed in a sense. They're just sitting in the lab, and if somebody wants to test their rotor, they just go there and test it, and they can see whether it spins or not. So I'm not sure what how the question is meant. You have no temperature at the moment. We don't have a temperature control on this because you would need an extra unit for that. But usually we don't spin them to the highest speed when the sample is in. So if people want to test their packed rotors, they just see whether it can do a few thousand kilohertz, and then you can do that a few minutes without temperature control.
Okay.
Without killing your protein.
Yes,
hopefully.
Definitely. Makes sense. And then we have a last question here. It says that this person is managing a big NMR core facility with around 150 users. So quite a big facility. I am really interested in signing up for Cluster Market, but they're worried about the adoptions by the users. How did you, or how were you able to enforce or entice your users to use Cluster Market and jump on the platform? Konstantin, how did you do that in your facility?
It was basically effortless because our previous booking system was very, very old. And basically, we couldn't run it anymore because of the security issues. It was written in a specific language that was not supported anymore. So then we found Cluster Market, and basically it was no, if I might say it, not in a very good way, we had no choice. We switched to something modern that works well. And indeed, at the beginning, we started with a relatively small group of users. So we only switched for manual measurements to use this system, but when we even adapted it for undergraduate teaching, so we have a separate facility created in a Cluster Market for undergraduate teaching, where we have every year 750 students. So it's relatively effortless. There are obviously, I believe that some convincing sometimes is required, but to be honest, the system over years, we started to use it quite a few years ago when it was still called BookKit. And I would say the system evolved over years. It looks more user-friendly now from my perspective. So it was not really a lot of effort.
Thank you, Konstantin. How did you do things, Elvin? How were you able to entice or bribe your users to jump on a new platform?
Yeah, we had before this a homemade booking system, which worked also very well. But then it had to change to another server and IT things. So I got to book it back then, Cluster Market nowadays as well. And also in general, quite effortless that people, they make their reservation so that they know they have their time on the NMR. And for overnight measurements, people have to stick on that. And sometimes I'm quite strict. So if somebody did not register, then I'll just go to that person and ask if he or she has registered. And if not, please do it, or make room for the people who have, because our nights are full with the measurements. Our capacity currently is sometimes low. But that's very scarce. Most of the people use it without any effort, so it works pretty well.
That's great. And Johanna, how was your experience with this? Did you have to buy them donuts or something for?
I think was the other way around. We started to use it in the wet lab, and then it was kind of natural to also have the NMR machines on it. And I think as a manager, or the person what you do, the people have to follow. If they don't book the NMR time, whatever system you give them, they just won't have NMR time. So I don't think it's that complicated unless they're completely against it and have a different system. Before that, we just used Google Calendar, but it's a small with solid state particles, it's as well. Few people, few machines, so that was also an option.
Okay, I know we are right on time, but we have a couple more questions. Here's one that asks, we are a big group with 200 plus users. How can I set up different groups and manage them, edit and search individual users by some ways? So I can answer this one. In Cluster Market, you can manage different groups of users by creating customized groups, and you can set different rules on each group. And then searching individual users, you can do that on a user tab that we have well organized. We have two other questions that Konstantin was nice enough to answer them, typing it, but I'll read them out loud so users will know them as well. Talking about the recovery in here, someone's asking what's the percentage. Konstantin replied that they recover around 50% of boil-off gas, and they liquefy them to have helium. And it can be up to from 80 to 90%, but it will depend on the configuration of your facility. And of course, a lot of technical details influence the recovery rate of the gases.
Can I just add one tiny detail? Maybe it was not clear. Those 50% is what we actually produce in liquid helium. So we technically get more gas, but something is lost during purification, of course, because there are no perfect processes. So it's those 50% is what we received as a liquid helium from our system. So it would be slightly higher, maybe 60%, I would say, of the gas. It also strongly depends how instruments are configured and how they are positioned, because we have in chemistry site, it's not one unique place. There is 3 rooms in different parts of the building. So as longer your connections, as more infrastructure you need, as more losses you get. Helium is very light, it's very difficult. So there is always some losses in the piping and so on. So it will strongly depend. If you have one unique room with everything inside, you can recover up to 90% of your gas.
Okay, that's super interesting.
Maybe to add onto this, because now when you get a new NMR machine, in the past, the people have been very reluctant, and the people charging the magnets very reluctant to do that at connected to the recovery system. And I think Broker is changing this. So it's worth talking to them how they can install your magnet and recover helium. The helium used for cooling during quench might be more difficult, but I think nowadays this is really something one has to think about.
Yeah, we develop our system with Broker. So when we started to think about this, the system that we own originally was developed for different type of instrumentation. So 10 years ago, we built that part that connects NMR to it. So we contacted Broker because there are a lot of technical details that only Broker know in terms of what should be the maximum pressure in your system, what should be the minimum flow. So they are very, very keen in help with this. So they were very, very useful. So in our case, we were very lucky to have them on board. So they basically advise us which parts we need to add to the magnets.
Definitely. And then we have one other question here, which is about using Cluster Market. How do you manage booking for users who require less than 15 minutes of time on the machine?
I can answer this probably without you reading it. Would be, you see, we use a different way of managing. So what we book in the system is not really the acquisition time. We book the access time to our instrumentation. We have too many users. That's why we cannot physically schedule 150 people coming during the day to the same instrument. It will just not work. So what we ask them to think rationally and to bring more than one sample. So instead of going 4 times with 1 tube to the NMR instrument, that they can group this and come once with 4 tubes, for instance. Then those 15 minutes would be not the overall time of measurements. There would be that time required for them to place tubes inside the robot, program them, change something, clean after them, and so on. So that's how we do. It's not an ideal scenario, but that's how we adapted it for our facility. It is much easier, and we don't use those minutes booked for counting the overall usage time.
And as well as Cluster Market, we want to support the NMR community, and we know that sometimes the experiments run for a minute or even less, right? The runtime of an NMR sample. So we are looking into lowering that time for 5 minutes or even less. So we're considering that and looking into it. It's on our roadmap, so we'll get there as well. So I think those are all of the questions. So I would just like to thank everyone that has been with us for over an hour, and thank our splendid guests for today, Konstantin, Johan, and Elwin. I just want to thank you very much for being here and sharing your experiences and insights with everyone. And just to do a quick summary, we talked about different advancements in NMR technology and different techniques that our guests are using in their facilities. We touched upon operations in NMR labs, including maintenance, how they do things, tips of how to increase lifespans of instruments and probes, tips about how they manage consumables and reducing waste, even recycling some of the cooling gases, and different best practices around the lab in general, including a lot of heft in training and communication with your users. So with that, I just want to thank everyone again, and hopefully we'll be seeing you on our next lab talk. Thank you, everyone. Bye-bye.
All right, thank you.
Thank you.